everyone, in this video we are going to use another technique. The technique called is embedding. So we are going to use a sentence transformer to convert our text into the embedding, which is nothing but the vector representation of our text, and there is a library called sentence transformer which is built on top of transformer high increase transformer. And for today's video we will focus on getting that embedding and actually using that embedding to build a text classification model. So the primary we are going to use that embedding is nothing but the feature for our model. For basic, if you think of, you can install the sentence transformer using pip install, and what it does, it simply declare which model you want to use, a transformer model that you want to use to convert your text into the numerical or vector representation. We called it as an embedding. So you can have a simply list of sentences or a text, and this model sentence transformer model has a method called encode which will simply take your sentence and convert into a numerical representation. We will see that is pretty simple, just 2 lines of code. If you wanted to know what are different models it use, so you can go here, and this is like pre-trained models. You can go to this section and it will tell you all the models available there, and they are saying that this is the best model they have and this is the fastest model they have. So you can choose as per your use case for you, and you can try multiple model and you see which one works for you. So this is what we are going to use today. So let's do one thing. First of all, let's install that sentence transformer, and I will also import pandas and numpy, and I will set some seed because I want to have a reproducible results. Next thing, I'm going to import the sentence transformer class from this particular library, and then sentence transformer class take the name of the model that you want to use. So I'm going to use this particular model. That from that list you can decide which one do you want, and it also supports the model on Hugging Face Model Hub. So if you go to the Model Hub, there are a lot of different models that you can find. There are 124 models available, right? So you can see which one suits for your need and you can use that particular model. But the model we are going to use, I think that is the default model. They have this one which is the default model. That's what we are going to use. The other thing, let's load our data set. Okay, and you could see our data contain a simple thing. We have a text which is actually some comment, and we say whether that comment is a toxic or not. So that is something. If there are something hateful or abusing words, then we will call it as a toxic. So that is the data set which what we have. Next thing, I'm using Spacey from Spacey I'm getting those top board list, and then I'm importing the string module here. We have put it string, so let me get some punctuations from that string library because we are going to use this two things while cleaning our data set to do pre-processing again. This is the function which is nothing but some kind of a token, either which take our text passes our text through the NLP, which is nothing but our Spacey model here that we have loaded. Spacey returns those lists of tokens. We can iterate through that tokens, and then we can take the lemma, make it lowercase, and strip any white space for each of those tokens, and then finally this particular state removes if they are in stop words in our tokens, or if that token is a punctuation mark. This is where what we are using. That's a simple thing it does. So if I call that Spacey tokenizer on particular sentence, you will see it has deleted I and M, and we got only happy. Maybe if I put happy as a capital H here, and you see we got only lowercase because it's going to make it lowercase. And maybe let's say if I do eating, let's make it again with capital E. You could see the first thing, it removed this thing at the stop word. Second thing, it converted eating it into this lemma, the original form, which is actually it. And then it also made it lowercase. That's why you are seeing this eat particular thing. And since we saw how it works, we can apply that same function, that Spacey token, either what it did for single centers. to the whole data frame column. So this is our column text. We are going to apply this function so that the resulting tokens will be stored here. Okay, I think one thing that I'm missing told you once I get tokens actually, which is nothing but list of words, but then I'm again using this thing to join those particular things, so I'm not sure whether in Python for this thing. So for example, let's say I have something like this word, let's say, and I'm just taking some random words actually. Let's say there are these two words called happy or apple or something like that. But if I have such a list, then I can convert this list of words into actually a string. Which is for that I use this thing, and which is the separator. How do I want to separate? So I want to separate via those, and then there is a math join, and then there is the join method which simply going to take our list. It is saying that I want to join element from this list using this separator which is the space, and so it will convert this thing into this is actually a string, and that separator you can decide you might want to join by dash, and it will join it by dash. That's what it does. So in our case, we clean those words, and then finally I convert those words again into the string format, because that's what our sentence transformer is expecting. We can do this. Let's see how does the output look like. So you might see this is the original sentence, and this is what. So you might see we again get sentence only, but then this y has become, or we have removed this word. This is also stop word. This particular what has become lowercase. So we got in a sentence format itself, but we have removed the stop words and punctuation mark like this. Everything is clean now. Now once we have data in a clean format, let's do one thing. Let's encode this text into the numerical representation, and that's what we are going to do. Again, just like we saw, we can call the model.encode on a text using panda syntax. What we are going to do, since now our clean data is the tokenized column, we are going to call data tokenized on this particular column. We are going to apply model.encode function. So what will happen, it will iterate through each of this row. It will take this particular text and then apply model.encode value, and whatever the output of this will be some vector representation. It will both get stored into this embedding column. So you could see that we got the vector representation and embedding. You can call it for the clean text data what we had. And since now once we have this embedding, this is nothing, but you can call it as a feature vector. This feature vector, we can feed it into any machine learning algorithm. So this is one of the beauty of the transformer things what we have, right? You might not use the transformer models for your classification or any deep learning model for the classification, but you can use them as an embedding to convert our text into the vector representation, and then you can use any classical algorithm. It could be a logistic regression random to do that classification. So that's what we are going to do here. So let's convert this into the training and test data what we have. So we will take this data embedding column what we have here. I will convert it into the list. So instead of this data frame, it will become list of list, and this is our y column. So if you want to see what is exactly, so let's see what is the first element of that list of x. You will see this big vector representation. That is what we have it here. Now once we have our x and y, we can use this test train to split, make it like 20% test size, and I'm going to convert it into the train test data. I'm going to use a basic algorithm. So we are going to use the logistic regression. You can use any, it could be random for a student algorithm which is agnostic. That is what I said, right? This feature vector, you can feed it to any machine learning algorithm, logistics or anything. So let's create our logistic regression object and then call effect method on our training data, which is xtrain and ytrain. Again, same steps what we saw already, and then let's predict on our logistic regression on our test data, and also calculate certain metric accuracy precision record on our text. And what is predicted? So we see we got accuracies almost 88%, precision is around 87%, and the recall is around 89%. And how much data I had? 100 examples each, 500 comments for each class. If you compare this thing with what we got using both vectors, so accuracy remains almost same. It is still an 88% precision, which was 89%, which dropped to 87%. So we lost the precision by 2%. What about recall? It was 86%, we got 89%, so we lost precision almost 2.5, but we gained recall by 3%. Now it depends on your use case. You know, your value recall more or your value precision more, and you can always manipulate even your hyperparameters to gain whatever the metric that you care about. The idea was to show you how do we use both now. We have used transformer, which is the state of the art thing, with our classical algorithm like our logistic equation algorithm, because we treat transformer to calculate only the embeddings, nothing but converting our takes. Now these embeddings are very powerful. You can simply compare, you can take this embedding and find which is the closest embedding, or you can take this embedding, find dot product or a cosine similarity with each row, and whoever has the highest similarity, their text will also have a similar meaning, and that is what the semantic search, or you can check the cosine similarity. So I hope you found this video useful. Let me know in the comment section if you have any doubt related to it. Until then, see you all in the next video.